Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is count cyclic paths and it is of medium level. So today's problem is, I would say, pretty standard DP. It's not very difficult to think of the solution if you already have solved some problems on DP. So we'll quickly discuss what is the problem statement, and then we'll discuss the solution, and then we'll also discuss the code. At the end of the video, you can check out the description. You will also find the link to the code. You can check that out after watching the video. So let us quickly start with the problem statement. Now it says that we have been given a triangular pyramid and there are some given points and where O is the origin. O is the topmost part and it is the origin, right? So now you are given n number of steps and we have to find the number of ways such that a person starting from O can reach back to O in exactly n steps, right? So you have to take exactly n steps and you have to get back to O. So let me just show you once. So it is a triangular pyramid. So on the top we have O, here we have A, here we have B, here we have C. This is connected and this is connected. So actually the connection between A and C is present there. However, it is shown in dotted line in the diagram in the problem statement. It's just because it is at the back of the pyramid. They wanted to show it like a 3D pyramid, so that is why it is like this. But we must take care of this, that there is also a connection between A and C. They are not disconnected, right? So you have been given n number of steps. In one step you can go to any adjacent. So it is like just like a graph. It is a graph with 4 vertices and these are all the connected edges. So it is an undirected graph. Now in one step you can go to any other vertices which is directly connected to it. For example, I can go from O to C, I can go from O to A, and I can go from O to B, right? So in this way I can go to any of them I want in one step. Now I have to find the number of ways in which I can use exactly n steps, exactly, remember the word exactly n steps, and get back to O, right? So I have to tell the number of ways I can do this thing. So for example, if I have one number of steps, I cannot do this. There are no ways to get back to O, because if I do one step, I will go to either A, I will go to B or C, right? These are the three possibilities. But if I have two steps, what I can do is I can go to A and then again I can go back to O. So this is one way. Similarly with B, I can go to B, then come back to O. Similarly with C, I can go to C and then come back to O. So as the number of steps increases, the number of the possibilities increases. Now there is one more important thing that the question mentions, that since the answer can be big, we have to give the answer mod some value, and that is 1e 9 plus 7, 10 raised to the power 9 plus 7. So this is the value that we have to give mod to. So let us quickly start with the solution discussion. Now here we know that if I have 0 steps left, right? If I have 0 steps left, then if I am at the 8th position, then my answer is 1, because sorry, if I am at the 0th position, it should not be 8, should be O. If I have 0 steps left and I am at the 0th position, then my answer would be 1, because there is only one way to reach O, that is by doing nothing. If I have 0 steps left and I am at any other position, A, B, C, or A, B or C, if I am at any other position, my answer would be 0, because by utilizing 0 steps I cannot do anything, right? This is my first intuition. Now I can form my DP states such that DP of n and DP of s. So n denotes the number of steps left, number of steps, and s denotes the state at which vertex I am currently, right? So this will be my DP states. Now the reason I have taken n before s is because like in C++ when we use, it's generally calculated in row measure. So if we take the bigger integer here, it is generally a little bit faster, because C++ uses row major order to calculate the array indexes. So now we have done this part. How do we know the answer for each state? For example, if you are at the S state, you know that there are exactly 3 more states that you can go to. If you see carefully, then every vertex is connected to 3 vertices. Right, from B you can get to A, O and C. From A you can go to O, C and B. So similarly for each vertex there are some other vertices that you can visit, and there are exactly 3 of them, right, for each vertex. So for example, I go to X, I go to Y, I go to Z. So these are the 3 vertex I visit. When I go to these vertices, if I had n number of steps left here, then for each of the vertices, I'll have n minus 1 steps left, right? And my answer for this particular state would be the summation of all these, because I have to find the total number of ways, right? So if I can visit X from S and Y from S and Z from S, so I have to find the number of ways I can reach to state O with zero steps left. Similarly, from here also I have to find the number of ways I can reach state O with 0 number of steps left. Right. So this is the ending condition, right? This is the condition where we have our answer equals to 1. Right. So we have to add all of these values together to get our answer for our state n comma s. Right. So this would be the final solution. What is the base case? Let me just start from again, right? Start from the starting. So we have been given a kind of a directed graph, we can say, where each vertex is connected to 3 other vertices, right? In one step, you can go to either of those vertices which are directly connected to the current vertex. Once you go, the number of steps decreases by 1, and at the end, what you have to do is you have to go to the initial starting position O with 0 steps left, right? Because you have to use exactly n number of steps. That is why when you are at the O, there should be 0 steps left for it to count as a valid move, or for it to count as a valid ending. Right. Now we discussed that we will form our DP DP, two state DP in n comma s, such that n is the number of steps remaining and s is the current state. Right. We will initialize. So this is the base case. So we will initialize our base case such as dp of 0 comma 0 is 1, because when we are at state 0 or state O and there are 0 steps left, then we have finally reached our destination and the answer would be 1 in this case. Otherwise, when we have 0 steps left and we are at any other state other than O, then we have not reached our destination and our answer should be 0. Now, this is the base case we have discussed. Now, we have the general case here. What do we do in a general case? If we are at any state n comma s, then we realize that there are exactly 3 nodes that we can visit from it. From state s, we can go to exactly 3 other states. Let those 3 states be x, y and z. Now, whenever you visit one of these 3 states, the number of steps would be reduced by 1. So if you had n here, the number of steps in this particular state would be n minus 1. And since these are independent ways, to find the total number of ways starting from n comma s, you have to add all of those 3 ways, and make sure that after adding we do modulo the mod that we have been given, right? So this would be the solution for today's problem of the day. There is one more very important thing that I would like to mention. Since we have to, like, for every state we have 3 other possibilities that we can visit, it is very reasonable to name them something different so that it is easier for us to visit them, right? We don't have to form if else conditions for all of the states. So for I named them in such order such that the top one is 0, this is 1, this is 2 and this is 3. Now I'll explain you why I named them this only in clockwise order. So this helped me, like, in getting the information of which nodes I can visit from the current node. So for example, if I am at 0, or let me just take the general case first. If I am at any state x, the number of nodes I can visit are, the first one will be s plus 1, the second one will be s minus 1, s plus 1 mod 4, s minus 1 mod 4, and the third one will be s plus 6 mod 4. So this is just a simple observation that we can make, and like this will help me to calculate the number of nodes I can visit from the current node, like in constant time, and I don't have to set if else conditions for every node, right? So for example, if I am at node 1, I can visit 2, that would be s plus 1 mod 4. I can visit 0, that would be s minus 1 mod 4. I can visit 3, that would be s plus 6 mod 4. How? If I do 1 plus 6 mod 4, it is 7 mod 4, and it is actually equal to 3, right? So you can get these values by observation. Like I was just trying to find simpler way to get the nodes which are connected to the current node. However, you can also try to form a graph and just try to visit all the vertices in that manner. Everything is correct, but it's just that this method is simpler and it takes constant time to find out the states which I can visit from my current state or from my current node, whatever you can say, right? So let us quickly start with the code of this problem. So what I've initially done is I've initialized a global DP array which is of size. So actually what I've taken is 1e 6 plus 10. So this is the size that I have taken. So and the number of states is 4, obviously. So I have initialized it outside because when I was initializing it inside the function, it was giving me runtime error. So I believe the limit for initializing arrays inside the functions are around 10 raised to the power 5. So since it was 10 raised to the power 6, I had to initialize this outside of the function. So I just take my mod constant in mod as 10 raised to the power 9 plus 7. Now I just set the base case for every state at when there are 0 steps left. I just initialize it with 0, and for the state 0 I set it as 1, because this will be the case when I am at the 0th position or the 0th state with 0 number of steps left. Now I go from every number of steps from starting from 1 to n. So these are the number of steps that are being left, and there is also a loop for the number of states. Now I calculate the possible states that I can visit from the current state, that is x, y, and z, and each of them are j plus 1, j minus 1, or j plus 6. Now I have done j minus 1 plus 4. That is because it's just whenever the number goes into negative, you can add plus 4 to like find the equivalent positive in mod. For example, if I was at state 0, right, what I should have done is I should have done minus 1 to get 3, right? But I don't want this negative integer with me, so I do plus 4 mod 4. So this is a modular technique you will learn in modular arithmetic. So what it will essentially do is it will make it 3 mod 4, which is equals to 3 indeed, which I wanted, right? So this is just basic modular mathematics. You can learn it from any video on YouTube. And the third one is j plus 6 mod 4. So I've explained it. Why is it like this? Now for dp of ij, I just do dp of I minus 1 x plus dp of I minus 1 y mod. Similarly, I just add I minus 1 z also to the answer. So this is dp of ij itself and dp of I minus 1 z mod. At the end, what I have to do is, so I have n number of steps left, and I am currently at the 0th state, right, starting from 0. So this state will be having my final answer when I have n number of steps left, and I am currently at state 0, right? So I can just return it easily, and this would be the solution for today's problem of the day, count cyclic paths. I hope you guys were able to understand the solution. If you guys found this video useful, you can subscribe to this channel and also like this particular video, and you can also share it with your friends. I'll be posting such videos regularly where I solve the Geeks for Geeks problem of the day. So till the next video drops, keep coding, stay safe, bye bye.